If you're building AI products, probably a great amount of time is actually not programming, but literally staring at the screen and waiting for large language model to finish off task and pray to large language model God that everything goes well. But quite often it doesn't. There are millions of different cases where your large language model system just didn't work or say something stupid. And this problem becomes bigger and bigger in later stage. After the large language model system goes into production, majority of my time actually starts spending on evaluating, monitoring, testing because real world cases are really dynamic and unpredictable. Quite often, when we build a system, there are a few test cases in our mind that we are building towards. But once it goes into wild, customer will tell all sorts of different requests, different ways. Like I was building a meeting scheduler agent where I was expecting requests where people say things like, let's meet tomorrow 9 p.m. Sydney time. But in reality, the case will be much more complicated where people will say, I'm based in UK, but travel to Singapore next week and back to China the week after. Once your language model system actually put into your customer's hand, it is almost guaranteed to break or perform really weirdly in certain cases. And this is when you want to start iterating the system. And the iteration of large language model system is extremely time consuming because there are lots of different combinations of things because large language model is not deterministic, which means the result will be slightly different every time. And there are all sorts of different combinations of different settings like the prompt itself, the model you're using, the temperature, and how you break down the flow. If you're building agent, do you use function calling agent or you use the React framework? And most of the time, your large language model system is not just one large language model call, but a flow of different language model steps or an agent who can autonomously decide what to do next with different tools. So the biggest challenge is when you change one thing, you don't really have a good confidence that it is actually going to improve the system for all the cases. Like you might put a special prompt as bandit solution to solve a specific edge cases that you just captured. But this prompt might actually make large language model pay too much attention to this specific part of the task, but start ignoring some other parts of the prompt. So to gain real confidence, you do want to test system in many different type of cases. And that's why large language model system evaluation is such a big topic. It basically means how can you build a system to evaluate the performance of a large language model system against certain tasks so that you will have a benchmark to know if your new version actually improved. And most importantly, help you find the optimal combination of all the different settings and system design for the specific task that you're trying to complete. And there are a huge amount of public evaluation online on the internet, which is useful in some way where it gives you an overall idea about which model is probably the best in certain type of general task. But quite often it is not that useful because the task they tested is not exactly the task you want. So most time, I can't really trust the result from those public evaluation that people are sharing. Because I know almost certain when I test different models with my own system, the rank will be totally different. That's why it's important to actually build your own custom evaluation process. The most straightforward one that everyone is doing is human evaluation, which means you basically look at a log of the large language model system output and just eyeball the result to see whether it is good or not. And if you are a bit more sophisticated, you probably will set up some logging system like Lensmith or Phoenix to have better interface to log and review every single step in those large language model systems. In most cases, human evaluation is still the must-have and best thing to do, especially while you're building a system. But the problem is once your system goes into production, the volume of different cases to monitor and evaluate is so big. So it's almost impossible for you to do human evaluation on every single case anymore. Otherwise, either you or the system gonna break. That's why the concept of use large language model as an evaluator is so interesting and important. And the idea here is pretty simple. Instead of getting human eyeballing the result to decide if the system is delivering good result or not, we can build a large language model evaluator, complete the same evaluation task so that it can handle huge amount of volume and scale very well. And sometimes the evaluator can not only be just large language model, can also be code to write down some hard code rules and do heuristic evaluation. Like if the code generated has error or if the answer or exactly match the math formula. So such an automated evaluation system is critical to launch any production level large language model system. But it is not always clear how to build such a system, especially how can you build such large language model evaluator that almost as good as human to decide if a system is performing well or not. That's why today I want to share a bit about how can you build such a large language model evaluation system so that you can really speed up the iteration speed and increase the level of confidence for both you and your customers. But before we dive into this, I know many of you are going through a career change or looking at starting your own AI career. But have you ever thought about how to leverage AI to land on your next dream job? So HubSpot did a research about how the new generation of job seekers are utilizing different AI tools or platforms to streamline their workflow and to be much more effective at the job hunting process. And they share a collection of all sorts of different AI platforms and startups in this job hunting market. From how to scrape and collect all the job information using AI to find the ones that suit you the best, to craft a standout application that catches the eyes of a recruiter and a hiring manager using AI, as well as simulating the interview process with AI so people can feel confident even before jumping on the actual interview, to even salary estimation to get a good understanding of how much you're actually worth. So this was quite refreshing for me to understand two things. One is all the possible ways that you can already utilize AI to help you land on the next dream job. And second, it is also a good way for me to understand what does the AI stack look like for the job market, which definitely inspired me a few different business ideas that we can potentially build to help job seekers. So I definitely recommend you to download this free report about how people are land on dream job using AI. You can click on the link in the description below to download this report for free. Now let's back to how do you build an evaluation system. So there are a few steps. You will need to choose a matrix that is most important to your system. And then you will build an evaluator that can actually provide evaluation result based on this matrix. And third is optional but really important. You will also want to prepare a golden data set that you can use to really test and recalibrate your evaluator to making sure it can deliver the human level performance. And after that, you can start testing different system variations and compare the performance. So firstly, choose the right metrics for your large language model system. This is the first and most important step. So you want to choose a metrics that you really care. And most times the way I would look at it is after I doing some eyeball testing, I start getting a sense about which part of the system can often break. Those are normally the ones I want to design some kind of metrics around it to be able to get a benchmark and evaluate against. For example, if you're building a RAG system, two parts you probably care the most. One is the retrieval, whether your system actually retrieves the relevant knowledge base at first place. And second is generation. Does the large language model actually generate a result based on the information provided, or did it actually hallucinate? And if those two are most important things, then you can design some metrics around those two things. So you probably have metrics of contextual relevance, where input will be the user query as well as the retrieved documents, so that we can decide is the retrieved knowledge actually relevant to the question. Second probably will be faithfulness, to really test is the generic answer actually grounded by the data that it retrieved, or did it actually hallucinate? Different systems can have really different metrics. For example, if you are building a customer support chatbot, where even though the majority of systems are very similar to a RAG system, but you probably in this case you also care about the real-time UX, because you can almost always adding more kind of steps in the flow to improve the retrieval relevancy as well as generation quality. But you actually don't want to sacrifice the user experience and getting user just waiting for a long time. Then you probably put a latency metrics as well, which is how long does the whole system to generate result for the query. If I'm building a research agent, I probably care about a couple of things. One, is this agent able to do as much of research possible to gather all the information relevant? And second is whether the final report generated are actually grounded by the information collected. And if you're building a kids tutoring app, you probably have some special metrics. Is the answer provided age appropriate? So the key point here is that the metrics are very diverse. And you should really look at which part of the system that often break or unstable and you really care, and design a metrics around it. And when you design metrics, there are probably different things you will be thinking about. For example, you might put a numeric metrics, like getting large language model to provide a numeric evaluation from 1 to 5. Or you just getting a language model to generate a binary classification. Is the answer correct or not? And the large language model can only output correct or incorrect. And you can even get a large language model to generate two different outputs, as well as some combination. But from my experience, the large language model is not really great at numeric evaluation. It often fails to give very precise or parameter-based evaluation. But when we get large language model to do binary or even multi-output, it is actually performing really well. So I often almost go for the classification or binary type of evaluation when I use large language model. And after you choose the metrics, the next step is actually build an evaluator. So you want to build an evaluator system that can actually evaluate the performance of large language model system just like human. To do that, you will need to decide two things. One is what will be the data input that this evaluator should get. The input can be as simple as a user query plus the output of the large language model system, but you can also include some reference data set if you are preparing a data set with a predefined list of tasks that has ground truth, so the evaluator can use that to compare. On the other side, the input can also be the result of specific step like knowledge retrieval instead of the whole large language model system. Then the evaluator basically needs to generate output, which is the evaluation metrics that you defined earlier. So if you're building a RAG system where you want to measure the retrieval accuracy, then you will have an evaluator that the input will be the user query as well as the retrieved data. And the evaluator will take this to input and generate output, which is relevance classification. They can either be relevant or irrelevant. Actual evaluator here most likely be a prompt template that you have designed. Like for this one, it can be simple as you are comparing a reference text to a question and try to determine if the reference text contains the information relevant to answer the question. And here's a question, this is a reference text, and now compare this two results and output only relevant or irrelevant. You can give very specific description about what this relevant means and what this irrelevant means. On the other side, if you're not building a RAG, but actually an agent that should follow specific process, then the input can be the system prompt that you give agent that contains specific SOP or process that it should follow, plus a full chat history that the agent generated. You can give those three different things to the evaluator and output the metrics to be whether the agent actually followed the instruction that it was given, and second, whether the agent actually completed the task. And sometimes you can even get evaluator to output the reason as well. So you can understand better if the agent is not following the instruction, which part did it miss. If I'm building a company research agent where I want to test whether the agent has ability to gather as much information as possible, then input can be the combination and list of data points that it should research about, as well as the final result that the agent generated. Pass on all those things to the large language model evaluator and output if all information gathered is yes or no. And this is a prompt that I used for this evaluator. It will basically pass on all those inputs and then say evaluate the result from the research system, decide if the system found the answer to all the data points provided. The answer can only be yes or no. So how you design the evaluator prompt really depends on the metrics you pick up at first place. And the real question here is how can you making sure this evaluator prompt actually give accurate evaluation just like you do, so that you can have confidence in the result it provided. So that's where the third step is quite important, to prepare a golden data set. So this basically means you can prepare a list of testing case, which including both input and output, as well as what is a correct evaluation result. For example, once you have this data set, then we can basically still run the evaluation by taking the input output and generate an evaluation result. But then you can compare this evaluation result to the correct evaluation result and decide if this evaluation is correct. So you're pretty much creating evaluation system for the evaluator itself. You can run multiple different cases on this evaluator with your golden data set to get an understanding about how accurate this evaluator is. And the question here is how do you get this golden data set? So there are a couple of different ways. The most straightforward ways would be manually curate data. So you can just create probably a small set like 20, 50 or hundreds of those manually created data sets where you can just give the correct evaluation result as a reference. But on the other side, after your system going to production, you will actually start getting a huge amount of real user log. And with systems like LLM or Phoenix, you can also go to those systems, look at user log and manually annotate your evaluation output as well. And that's why in systems like ChatGPT, they will give you some thumbs up and thumbs down button to provide feedback. If you're just getting started, you can even try to use large language model to generate some data set as well. For example, if you're building a RAG system where you want to really push the retrieval accuracy, you can actually get a large model to generate a bunch of different cases by loading website and generate a list of question retrieval and output result. But no matter how you get this golden data set, the idea here is you can evaluate your evaluator, iterate it to a point where the result is pretty accurate. So that in the end, you can actually put it live and start testing against different variations of your system and compare the results between different systems in terms of the metrics you define, the latency and the cost. And that's pretty much it. This process might sound a bit cumbersome, but in reality, it's actually very easy to set up with systems like LLM and Phoenix. I'm going to give you a quick example of how can I create an evaluation system for a researcher agent that I just created. So I want to show you an example of how I built an evaluation system of a web research agent that I built before. All the details and source code in a different video, so you can check out if you want to dive deeper. And the key things I really care and want to test a lot is about the research agent's ability to gather as much information as possible from different data sources. So the metrics I define here is the info gathering, whether the agent actually found all the necessary information that the user requests from the internet. So I'm going to show you a step-by-step example of how I set it up and how I use that to compare the performance of using the old GPT model versus the new GPT-4o, whether it actually delivers better performance with cheaper cost. But to set up, there are really 4 steps. Firstly, we want to use a system to actually log the user requests to your large language model system. And there are multiple different platforms you can use, common ones like LLM, or there are also open source version like Phoenix, where you can host yourself. And once you set this up, you can start all the user requests and build a data set out of it by annotating the result. And then we're going to create an evaluator to deliver the evaluation result so that we can start evaluating against different models and variations and compare the result. So that's it. Firstly, the setup of logging system. And the one I'm going to showcase is LLM. And the reason I choose that is because they kind of have the both evaluation, logging, and annotation kind of connect together, which makes this process a lot easier. So I'm going to go back to my agent scripter project that I did last time, which is basically an agent that can receive a website URL as well as a few research topics. And then this agent will go to the company website to research all the possible information there. And if nothing found, it'll also go to public internet to find more information. And as I mentioned before, I've demonstrated the source code in another video, which you can check out if you want to learn more. But this is basically the agent I created before. And as you can see here, I actually didn't set up any tracking. And to set up tracking is actually very straightforward. So the way LLM or any other logging system works is basically you can add some special decorator to the function that you want to track by adding this add traceable before your function. And they will also provide some help function to automatically track all the large language model call as well. So all we need to do is just add this traceable decorator to every single function that we want to track. The first step is we want to install LLM. If you haven't installed that yet, you can just do pip install LLM in your command line. After that, you will need to create an API key and then copy the API key to your .en file. One for LangChain API key, and also you will need to turn on this LangChain tracing v2 to be true so that it will start tracking. And if you want, you can also define a specific LangChain project that you want to log all the information. And at default, all the data will automatically go to default project if you haven't specified that. And once you did that, we can go back to our researcher.py file and firstly import two libraries from LLM. One is traceable, another is wrap OpenAI. So I want to replace this OpenAI.client to be wrap OpenAI.client. So all the large language model code will automatically be logged in LLM. And then for every single function that we want to track, we can add the add traceable decorator. So for the scripting function, I can add this add traceable, and you can define a couple of things. And one is run type. It can be tool, it can also be large language model. Basically, the purpose of the run type is identify them differently in the LLM. So some will be large language model, some will be the tools, and at default will be changed. As you can see here, each log here has a different name. This is the name that you will define here. You can basically do add traceable, run type equal to tool, and name equal to script. I'm going to do the same for the internet search function. So just before this function, I will add this traceable, run type equal to tool, and name equal to internet search. Same thing for update data. Also add to this chat completion request as well to track this agent chat completion. For this help function where it is to log the information in my command line, I don't really need to track this. I will skip it. Memory optimization, I also want to track it. So I'll just add decorator traceable name equal to optimized memory, as well as call agent. And same thing for the two different steps. Traceable name equal to number 1 website domain research and the number 2 internet search. In the end, the last one, traceable for run research. That's pretty much it. After I set up all those traceable, next time when I run this researcher agent, it should automatically log the information into LLM. So I can open terminal, do python researcher.py. I can say start running. Okay, so the agent has finished running on my end. Now if I switch back to LLM, you can see this new session show up already. And if I click on that, you can see the full trace of every single step the agent did to complete this task. So firstly, there will be a run research, which is top level function that we tracked here. And then the first stage is website domain research, which is one of the first stages that we track here called number 1 website domain research. And inside that, you can see every time when a certain function has been called, it will be automatically tracked from the agent chat completion and optimized memory. I can also click on the top level number 1 website domain research to see the output of the first stage is that it didn't find any information on the website domain from Discord. That's why it triggered the second stage of the internet search. In the end, it found the result for every single field eventually. So that's pretty much it. From this point, every single time when a user have a research task, the information will be automatically logged into the system. From there, you can actually start creating a data set that can be used for evaluating the system. So you can see there are two options here. One is add to data set and another is add to NLQ. So annotate basically allow you to give your human evaluation result to create that golden data set. Probably you won't see any metrics here yet because you haven't really connect any metrics to this project. But once you set up, you can actually give your human evaluation. But on the other side, you can just add this to data set as well. So data set is basically a collection of different cases that you want to test, including both input and output. You can create a new data set. Let's say web scraping research agent. Click create. And you can also make change to the input and output here as well if you want, and then click submit. Then this testing dataset has been added for you to test later. And if I switch back to the dataset tab, you will see this new dataset called Web Scraping Research Agent. If you click inside, this one example here from your user log. And you can basically just repeat this process to look at all the user log and pick up the good ones that you want to use for testing later. Because for each one of those datasets, you can actually create evaluators. So LLM do provide some UI for you to create a new evaluator. You can choose some of the templates that they already have, but you can also create your own. But I'm going to show you how can you create in the code directly. So in our case, as I mentioned before, the key things I want to test is, does this agent system collect as much information as possible for all data points that it requested? And for that purpose, I will just create an evaluator to test just that, whether all data points user request has been collected. So I'll flip back to our Python code. And first, I import two new libraries. One is evaluate. This will allow us to run evaluation. Let's say you have a few examples in your data set. The evaluate function will basically run your latest large language model system against this data sets and do the evaluation. And we'll also import landsmith.schemas to import run an example. So run means the actual output from your large language model system. Example is where you can get the reference information from the example data in your dataset. And then I will firstly create a function called research eval with inputs. So firstly, we will try to get a few inputs from the testing datasets. One is entity name, website, data points. Those are basically the input variables we have in the testing dataset, which is website, entity name, and data points to search. And then I will do the run research function that we create above and return the data points as output. Then we're going to create the actual evaluator. So the evaluator I'm going to create is all data collected check. And we have two input. One is run and another is example. So we need a run to get the actual output from the large language model system we built. An example will allow us to get the reference output as well as the test case inputs. So we'll get all those relevant data, company, data points, result, and ground truth, which is reference output. Then we will put together a system prompt like this. So I basically just pass it on both the research task, the result from our research system, as well as reference result from the human researcher, and ask it to evaluate if all the information has been collected. It can be either yes or no. And then I basically use a model to do this evaluation. In here, I did actually use the same model that I was using for the large language model system, which normally is not the best practice. Most of the time, you do want to use a different model to do the evaluation. But in my case, I'm actually not testing the model itself. I'm actually testing the output of the whole agent system. So I still use the same model just for convenience. And in the end, I will do a transformation. If all information found is yes, then I will set a score to be 1. Otherwise, I will set a score to be 0. The reason I do this is because in landsmith, once the metric is actual number, will be able to give us an overall score across all the test cases. For example, in this specific one, 1 out of 4 cases actually succeed, and all the other 3 cases fail. So it gave me an average score of 0.25. So that's quite useful to get a summary of the experiment. And in the end, I will output key to be all info found and score to be the score we output. And so far, I couldn't find a best practice about how to output multiple different metrics, because unless it seems like one evaluator can only output 1 score. But if there are any other good ways, please comment below and let me know. And in the end, I'm going to start a evaluate, where I will put a system function that we're gonna run to first parameter, the data set name, which is the one that we create here, the evaluator point to the function that we create above, and experiment prefix, as well as metadata. And that's pretty much it. So first, I do want to run a quick benchmark test with the model I was used before, which is GPT-4 Turbo. And I will open the terminal and run this script. So you can see the agent start running, which will take a while. But if I flip back to landsmith, you can see that there's a new experiment show up here called GPT-4 Turbo. And if I click inside, you can see all those 2 sessions are running in real time and showing us how much token it consumed and how much money it cost on large language model side. And if I click on this view trace button, it will show me the full trace up to this point. Now you can see that the evaluation has finished. If I switch back to the landsmith, so the result you can see from our very small testing cases is 1 case succeed, 1 case fail. And I can click on the view trace button to see the result. So test is basically, I ask agent to search 3 pieces of data about Discord, about a certain company. One is whether this company provide catering to the employees, how many employees do they have and what different office locations are. And the result is that the agent didn't really find whether the company provides catering, but it does find the number of employees as well as office location. The other case is the same list of data points, but different company safety culture. And this time it successfully find the company actually offer in-house catering to the crew for breakfast, lunch, and snacks. And there are roughly 696 employees and 6 offices in total across those locations. And you can see the evaluation result also reflect that. So the safety culture all info find is 1 versus Discord all info found was 0. And if you want, you can actually click inside and copy paste whole input. So now we have this benchmark about the GPT Turbo performance with our system, as well as latency and token cost. And you can see that it roughly costs from $1 to $1.6. So let's say now we want to test whether new model GPT-4 actually improve the performance, and ideally with cheaper cost as well. So I can just move up and change the GPT model to GPT-4o and run this test again. So the GPT-4o test also finished. And if I go back to the last miss, you can see this new one called GPT-4o experiment. If I click inside, great. So both of them actually succeed. If I click on the first Discord one, I can see they actually find some specific information for every single piece of information we need. And I believe the overall cost to complete the task is going to be lower as well, because we can click on this add button and compare with another experiment we did. In this case, it will be GPT-4 Turbo. So you can actually compare side by side. With the similar cost for Discord case, the GPT-4o actually costs a little bit lower, but completed the task successfully. And for safety culture test case, they both complete tasks, but GPT-4 Turbo complete tasks with much less cost. And if you want, you can even do another test with, let's say, GPT 3.5 Turbo. Let's change the model as well as the max token. All right, GPT 3.5 also finished and actually finished really fast. The question now is, did it actually complete task? So if we go back, you can see that GPT 3.5 just completely missed the mark, even though it's extremely cheap. And again, we can add a comparison with all the other 2 variations we just did. To do this properly, you probably need at least 20 or 30 different test cases. But you can see how powerful this one will be for your iteration process. You can just change some combination and run the experiment to get understanding about what's the real performance of your latest iteration across multiple different testing datasets. And if you know any other interesting evaluation system or best practice, please comment below. I'd love to try out as well. I will continue posting interesting AI knowledge and projects I'm doing. So if you enjoyed this video, please subscribe. I will see you next time. Thank you.